We'll start with creating the intermediate spreadsheet for retirement savings calculator. We'll start with cell B2, giving the heading retirement savings calculator. Giving the table headers of year, age, rate in percentage, invested amount, the opening balance, the interest, and in this one we'll be having a debit amount, and finally the closing balance. Moving the heading till column I and increasing the width of columns so that the text fits. Now I'm going to start from year 0 and we'll be calculating the retirement savings for 60 years. So let's remove the 61, hit delete, and start from, say, to format the table. Format as table, and we have headers. So we can remove the filters as well. Sort and filter, remove the filter. We can start the age from 34 to 35 and using the shortcut, double clicking on the plus and getting the values till the end of the table. Now we'll start with inputting one random value of the rate, let's say 2%. Now we'll be using a formula for calculating the subsequent rates that will generate random rates. So the formula goes like this. We say equals the right, and it uses the pi formula, the pi 3.14. It returns the last 2 digits of pi based on the row number of the cell that it is in. So right pi based on the row number that the previous cell is in, that is D5, and fill in the number of characters we need. We need 3 characters like 1.25, 3.14, 4.24. So this gives us 9.59. It gives the last 3 digits of the pi from the previous row. It's a random number generator formula. Let's say we have an initial invested amount of $10,000. We'll give the numbers of format for these cells of US dollars. And we have several options. We'll use the red font to represent a negative value instead of the minus. Now we can just copy the values or use the equals E4 for the opening balance, because for the year 0, the invested amount is equal to the opening balance, which is equal to the closing balance. Now let's say we decide to invest $2,500 per year, and that's from year 1 to 8. Then after a hiatus, we invest again $2,500, and then after some time period we invest from 20 to 24, and until retirement from 63 to 65. We have decided that the retirement age is 65. So we'll put in the opening balance formula, which is equal to the closing balance plus or we can say the sum of the closing balance, comma, the invested amount. Comma is used to represent the cells we are considering, the sum of A comma B comma C, which is equal to A plus B plus C. Similarly, the interest formula, that's the opening balance into the rate. We'll use the shortcut to fill in the cells. Now for the closing balance, we'll use the formula equals F5 plus the interest, that's G5. Now we see these hash written. That's basically because the cells cannot fit in the values. So we need to extend or increase the width of the cell, width of the whole column. Now we see these values, the rate values, they're not in percentage, but this extends them further. So we'll need to incorporate them into the formula. We'll put in the parentheses and just put the sign of percentage. So which converts it in the rate into percentage. We can do it either way. Changing the formula for the subsequent cells of interest column. Filling in closing balance values. Just putting a marker for the retirement age. So put a thick bottom border that separates the retirement with the subsequent years. Now we need to make a slight change because we'll be debiting amount. So we need to make sure that for the interest to be calculated, the opening balance is greater than 0. So we'll use an if statement. It has the formula equals if the value of opening balance, that is the cell F5, is greater than 0, or if F5 is less than 0, then we give the interest as 0. Otherwise, we give the rate as the formula we decided earlier. That's D5 into F5. And putting a percentage. So we'll need to remove the percentage from the rate formula because it has been taken care of in interest formula. And put this just as a number. So it's 2.00. Now we have calculated using the if formula. If the opening balance is less than 0, then give us a 0 interest. Otherwise, use the formula. Now similar is the case for the closing balance. We'll be debiting amount after retirement. So we need to decrease the debit amount from the closing balance. That is, we need to subtract H5. The closing balance would be opening balance plus interest minus the debit amount. This is because of Excel Online. It gets changed to US and English with the number format. We'll just use it again. Put the formula again. So right now the values won't change because the debit amount, there's no amount that's getting debited. But after retirement, let's say we start debiting some amount. Let's put in some random value of $150 and then a large value of $26,000. Let's say a fixed value of 2366 for some years, and then put in a large value of $150,000. And then some constant values of $2,366 for a few years. And then $20,000. And deducting a big amount of $150,000 again. Supposedly the person wishes to buy a car or something. Then putting in the values again, $2,366. Now we see the balance, the closing balance is getting deducted, getting reduced as we deduct the amount. Now, after we put in the value that's too high, the closing balance gets less than zero. The red font is used to represent that the closing balance is less than zero. So we see the interest formula work this time. Because we didn't have a positive opening balance, the interest is zero. Let's create an outputs table kind of to represent what we have been up to, the final outcomes of the table. We have the number of annual payments. Combine these cells using merge and center. And we can calculate this. Let's first add the color to the outputs just to signify a separate section. We can calculate the number of annual payments as using a formula of count equal to count open parentheses, and then we can select the invested amounts. That's the $2,500 amounts that we have invested. So it counts the number of times we have invested $2,500. Similarly, for the total amount invested, in this one we'll use the sum formula, but also include the initial invested amount. That's $10,000. So select those cells in the sum formula, close the parentheses, and press enter. Now we can use the format painter to move the subsequent cell similar to the same format. Now, to calculate if the person runs out of money or not, we'll use a formula of using if. Count ifs. Now, count if is used to check multiple values. So we'll select a range of values, well, actually from after the retirement age. That's I4 to the last cell, I64, but we'll actually include the cell that is after retirement. So the closing balance after retirement, that's I36. So from I36 to I64. And if the criteria is, if it's less than 0, we use ampersand and 0. If it's less than 0, then give us the value if true. If it's true, then we say that yes, the user runs out of money. You'll run out of money. The else case, when the no, we'll put in, checking the formula, we'll put in you won't run out of money. If none of these closing balance cells that we have selected from I36 to I64 don't have a negative value, then we'll print you won't run out of money. So less than sign, ampersand, we can select any value if it's less than 100, or if it's we can actually change that if it's greater than some value or whatever. So it says you'll run out of money because you can see the red font of 560. We are in 566 and 52 cents. That's negative value. So let's just decrease the debit amount, and we'll see that you won't run out of money because there are no negative values in the closing balance now. We'll just do some formatting of all the tables.